Okay, so the first one just says that you guys are just writing out the fractions. So we're going to look at sine. So remember, yesterday we had that phrase, some old hippie came a-hopping through our apartment. So remember, each of the letters, the first letter of each of those words are what we use to write out our ratios. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So if we're going to find sine of A, we want opposite of A. So what side length is opposite of A? 9. What is the hypotenuse? 15. So if we want to put this in lowest terms, how can we reduce this? What goes into both these to come up with that equivalent fraction? Yep, 3 goes into 9 3 times. 3 goes into 15 5 times. So 3 over 5 is our first fraction. Next one is we want to do cosine of A. So cosine we see is came a-hopping, adjacent over hypotenuse. What's adjacent to A? What's the hypotenuse? Okay, what goes into both 15 and 12? 3. So how many times does 3 go into 12? How many times does it go into 15? So 4 over 5. And then we have tangent through our apartment. Opposite of A is? Yep, 9 over 12, which she already put in lowest terms. 3 over 4 for our equivalent fraction. And now we're going to do all the same things, but now in terms of angle B. So what is sine of B? Opposite of B is? And hypotenuse is? We see 3 goes into both of those. We end up with 4 over 5 again. We have cosine. That's adjacent over hypotenuse. What's adjacent to B? 9 over 15. We reduce that to our lowest terms. It's going to be? Thank you, ma'am. And then we have our last one, which is tangent opposite over adjacent, which is going to be 12 over 9, which goes to 4 over 3 for its equivalent fraction. So if we want to find a missing angle, what we do here is we're going to be looking for an angle measure that is given, we're given at least 2 sides. We're going to have 2 sides of a right triangle. And we can find this by using an inverse. So far we've done tangent inverse. Today we're talking about sine inverse and cosine inverse. So the way you guys can do this on your calculator is the same way we did tan inverse, where you guys did second, and then whichever trig function you're looking for, it'll show with that -1 exponent, which you'll see like this, and that's how you know you're doing the inverse. When we're doing an inverse, we're always finding an angle measure. Always. So we're going to start here. So it says use a calculator to approximate the measure of angle D to the nearest tenth of a degree. So we want to use angle D, so that's what we're going to be finding. So which trig function do we want to use? Well, when we look at this, we see we have all the sides. We have opposite of angle D, we have adjacent to angle D, and we have hypotenuse of that triangle. So we could use any of the trig functions. So today, since we're talking more about sine inverse and cosine inverse, let's have you guys focus on using one of those two. Which one would you guys rather use, sine or cosine? No preference? Well, we use sine. So sine of angle D is, and so that sine is some old hippie, opposite over hypotenuse. What is opposite of angle D? 30. What's the hypotenuse? 34, nice job. So to find D, we do sine inverse of our fraction, sine inverse of 30 over 34. We're going to get an angle measure. (61.9). Okay, degrees. And then we want to find angle F. That's the second part of this question. So to find F, again, we have any option because we have all the sides. But since we use sine, let's try cosine. So cosine of F is going to be some old hippie came a-hopping, adjacent over hypotenuse. What is adjacent to angle F?
30.
Okay, so 30. What's the hypotenuse? 34. So we're going to apply that cosine inverse to both sides. So we have F equals cosine inverse of 30 over 34. What is cosine inverse of 30 over 34? (28.1 degrees). What do you guys notice about those two angle measures? We've talked about this a couple times. They are. What did you say? They are decimals. What do we notice? You combine these two, they're what? 90. So we know these are complementary. They are complementary. So for this example, it says find the measures of P and M to the nearest tenth of the degree, and also find the side N to the nearest tenth. So which one do you guys want to do first? Find the angles or the side? Angles? Okay. So let's start with P. So in reference to angle P, which sides do we have? We have adjacent and opposite. So which trig function is opposite and adjacent? Yep, tan. So we have tangent of P. And then where she's getting that is tan is through our apartment, opposite over adjacent. So opposite of P is 5. Adjacent to P is 10. So to find angle P, we apply tan inverse to both sides. So tan inverse of 5 over 10. So tan inverse of 1/2. $26.7 you said? 26.6, sorry. Looks like this, did I write it right? Perfect. Okay, and then if we want to find angle M, which sides do we have in reference to angle M? Reference to angle M, which ones do we have? Opposite and adjacent, which means we're using what? Tangent, yep. So tan of angle M equals opposite of M is 10. Adjacent to M is 5. So to find that angle, we have to apply that inverse. So M equals tan inverse of 10 over 5, which is just 2, which equals how much? 63.4. Oops, let's try that again. 63.4. And we can eyeball this and see that these two numbers are going to add up to 90, which is how we know we did it correctly because they're complements. But the last part says finding the missing side length. How do we find a missing side length? Close. A squared plus B squared equals C squared. The good old Pythagorean theorem. So we're going to be using this. So which one is going to be our C? What letter or number up there is going to be our C? N. Because remember, that's the only one that really matters, the positioning, because that's the one directly across from that right angle. And then the other two you can put in either of the other spots. What is 10 squared? What's 5 squared? Okay, we're going to combine like terms. So 100 plus 25 is equals n squared. How do I get n by itself? Square root. So we're going to factor that. What are some factors of 125? 25 and 5. And I really don't have to go any further than this because one of them is a perfect square. Square root of 25 is? The square root of 5 doesn't have a buddy. It stays locked up. So n equals 5 root 5. So if we would have found this first, we could have used any of the trig functions as long as we left it with a radical in it and it's an exact number. I'm going to erase that little bar there. I just had it because I boxed it in early. So this one says find the measures of angles B and C to the nearest tenth of a degree and then find side C. So let's do our angles first again. So if we're going to look at B, which sides do we have in reference to angle B? Adjacent, opposite, or hypotenuse? You have opposite and what's across from this one? The hypotenuse. So that makes it hypotenuse. So we have opposite and hypotenuse. Which trig function is opposite and hypotenuse? So we have sine. Some old hippie came hopping. Yep. Through our apartment. So she just told us that sine. So sine of B is opposite, which is 45 over hypotenuse, which is 53. So B equals, apply that sine inverse to both sides. What do we get? So 58.1? Okay. And then our second one is we want to find angle C. In reference to angle C, which sides do we have? Opposite, adjacent, or hypotenuse? We have the hypotenuse and adjacent. Which trig function has adjacent and hypotenuse? Yep. So cosine of angle C, we're going to do adjacent, which is 45, over hypotenuse, which is 53. To get that C by itself, we apply a cosine inverse to both sides. So cosine inverse of 45 divided by 53, which is what? Can you say it one more time? 31.9. Thank you. And then our last step is to find that missing side. So we have to use that Pythagorean theorem. A squared plus B squared equals C squared. So what is our hypotenuse? That's the only one that really matters position-wise. So which one's our hypotenuse? C. And which one is it of number-wise now? Is it going to be the C, the 45, or the 35, or the 53? It's going to be that 53, so we got to put it in place of that C up here, so 53 squared. The other two don't matter. You can place them either place. So 45 squared plus C squared. Can somebody tell me what 45 squared is? A big number. Can you say it one more time? 2025 plus C squared. And then this is an even bigger number. 53 squared. 2809, like this? Okay. So we got to combine like terms. I'm going to subtract over 2025. We're left with C squared equals, what do you get? 784. We're going to square root both sides. We have to see if we know the factors or if it's a perfect square. I don't know off the top of my head. Perfect square, what does it work out to be? 28. So we know that C equals 28. Okay, so it says use sine or cosine inverse to find these angle measures. So anytime we're finding an angle measure, all you're going to do is apply the inverse, so whatever trig function's there to find the angle. So the first one, sine of A equals 0.5, which means that we just have to do A equals sine inverse of 0.5. So apply that sine inverse to the other half, to the fraction or decimal, and what do we get? 30. Our next one's cosine. So to find A, we're going to apply cosine inverse. And we're going to keep that decimal on the inside, 0.92. What is cosine inverse of 0.92? .1. Thank you, ma'am. That's a terrible degree sign. There we go. And then our last one is sine again, so we're applying that sine inverse. So A equals sine inverse of 0.1149. And what do you get? 606. Thank you. That's how you said? 6.6. Okay. Degrees. And that is the end of today's lesson.